So I'm going to go over the Unit 9 test review. So number 1 says find angle ABC. So we're looking for this angle right here, ABC. And I notice that it is subtended by this arc out here, which is 168. And we know that angles are half of arcs that are inscribed angles. So that's going to be 168 divided by 2, which is 84 degrees. Number 2 says find these angles. So it's all these angles here that are vertices of our quadrilateral. So on this one, I'm going to first explain how I'm going to find the angles. So when I'm explaining the angles, I'm going to say when a quadrilateral is inscribed in a circle, opposite angles are supplementary. So what does that mean? That means these angles are opposite angles. So when I add those together, they're going to be equal to 180. And these angles are opposite angles. So when I add those together, they should be 180 because that's what supplementary means. So I'm going to solve for x first and then plug it back in and solve for those two angles. 2x plus 8 plus 5x plus 4, that equals 180. So that's going to be 7x plus 12 equals 180. So that's 7x equals 168. So that means my x is going to be equal to 24. Then I'm going to plug that back up in here in these angles. So 2 times 24 plus 8, so this angle up here is 56 degrees. And I could find that other one by just subtracting it from 180, but I'm going to double check and make sure. So this one's going to be 5 times 24 plus 4. So this one down here is going to be 124. And then obviously our drawing, by the way, doesn't look accurate, but don't let that mess you up. So then we're going to solve for our y. So here again, I'm going to do 4y plus 10 plus 6y, that equals 180. So that's going to be 10y plus 10 equals 180. So that's 10y equals 170. So y, when I divide 10 by both sides, is 17. Going to plug 17 back in both. So that's going to be 4 times 17 plus 10. So this angle here would be 102. And then the other one over there on the right is going to be 6 times 17. And that's going to be 78. And again, when I add these two angles together, the 102 and the 78, they should equal 180. All right, so now we're going to go down here to number 3, and it's asking us to find arc ACB. Arc ACB is this arc out here. What we're going to do is we're going to divide 360 because I see that AB and BC and AC are all congruent. So I'm going to divide 360 by 3. That gives me 120 for each of these arcs. So that's 120. This is 120 here. This is 120 down here. Then again, we're talking about this out here. So we're just going to do either 2 times 120 or 120 plus 120, and that's going to be 240 degrees. So number 4 says arc EA and arc EDC. So arc EA is down here. And notice that this is in percentages. So to find what that is in a decimal, we would just divide the 5 by 100. That would be 0.05 times 360. So that one for arc EA is equal to 18 degrees. So that's arc EA. EA. Then we're looking for arc EDC. EDC. That arc. So this one, let's do it in a different color so we can see it. Arc EDC is this one out here. So I notice that this one up here is 10. So we've got 10 plus 35, that's 45. Once again, we could divide that by 100 to make it a decimal, 0.45. times 360. And when I do that, I get that this one is 162 degrees. So that's arc EDC. Over here on number 5, it's asking us to solve for arc AB right here. Well, I notice again that I have some tick marks over here and here. So that means this one over here is also 123. So here again, I could do 2 times 123. That is 246. And we could subtract that from 360 because this is the part that's left. When we do that, we get that it's 114. That's what this is up here, 114. So for number 6, we should notice that we have chord AB is congruent with chord AC. That means that my arcs up here, arc AB, is congruent with arc AC. So we're looking for arc AC down here. So I know that that's not going to include my 78. So I'm going to do 360 minus 78. And that gives me 282. And then because these two arcs are congruent, I'm just going to divide that by 2 to find one of them. So that's 141. Now over here, the first thing I'm going to do with number 7 is label what I have. Angle DEA is this angle right here. So I'm going to put 24 here. And then BEA is right there. So I'm going to make this one 56. Well, when I add those two together, that's 80. So that means that this arc out here is 80. So that's 80 degrees. So then when I'm looking for angle DCB, that's this one right here, this angle, I should be able to see that that's the inscribed angle. So I'm going to do 80 divided by 2, and that's 40 degrees. All right, let's jump down here to number 8. I'm going to go ahead and do this in the drawing first. And I notice that I have an arc here that's 82, so I know that that central angle is 82. Got this arc out here that's 132, so I know that this central angle is 132, sorry. Now what I'm going to do to find this angle, notice here that I have half the circle, so I'm going to subtract 132 from 180, and that's going to give me 48 here. So if that central angle is 48, then this arc's 48. Again, we've got our half circle here, so when we look on the other side, same thing. So we're going to subtract 82 from 180, so that's going to be 98 here, which means this is also going to be 98 out here. The only thing that's left to solve for here is these inscribed angles. So we've got this angle here, which would be A, B, either P or D. Notice the arc down here is 82, so we're going to do 82 divided by 2, so this angle up here is going to be 41 degrees. This one over here, which would be CBD or CBP, again, our arc down here is 48, so for this one we're going to do 48 divided by 2, which is 24 degrees. So then we're just filling in the blanks over here. Angle APB. So APB is that angle right there. That was 98 degrees. Then we've got angle ABP. ABP is this one. It was 41 degrees. Then we've got AB, arc AB out here. That's 98 again. Then we've got arc BAD. I'm going to do this in a different color just so y'all can see it. Start with B, go around the A, all the way around the D. So we're going to add together the 98 and the 82. We do that. And that's actually half the circle, y'all. So that's 180. Then we've got angle APD. So APD is that angle right there. That's going to be 82. Then we've got angle ABC. So let me go ahead and mark that one. Let's see what color. ABC. ABC is this angle out here. So we would add together the 82 and the 48 and then divide that by 2. 82 plus 48 is 130. 130 divided by 2 is 65. So that's 65 degrees. Then we've got arc BDA. Arc B, start here, going to go around to D, all the way around. Wait, what did it say? No, I got to go the opposite direction, y'all. Sorry. BDA, my bad. So we got to go from B here around to D, and then over to A. So right there is where we're going. So we're going to add 82 to 48 to 132. And when we do that, we get 262. And then our last one is DC. And DC is right here. It's 48 degrees. Arc DC. So number 9 says find the area of the sector. We're going to use the formula pi r squared theta over 360. So the radius is 12, so we're going to do pi times 12 squared. Our angle is 60, or our arc. We're going to divide that by 360. When we do that, we get 24 pi centimeters squared. When we multiply by pi, it would be 75.4 centimeters squared. Number 10 says arc length, and so we're going to use the formula 2 pi r theta over 360. So we're going to do 2 times pi times 7, and notice it says with a semicircle. So r theta this time is going to be 180, and then we're going to divide that by 360. So when we do all that, we get 7 pi, and this is going to be meters, not meters squared, because it's just a length. And then when we multiply 7 times pi, we get 21.99 meters again. All right, down here for number 11. When we do number 11, you guys are going to have to explain this. So in the explanation, what I need you guys to say is find the area of the sector, and then subtract the area of the triangle. That's how you find it. So that's exactly what we're going to do. We're going to find the area of the whole sector. That's this, right? So we're going to do pi times 3 squared times r theta, which is 90. Divide that by 360. And then we're going to subtract from it the area of the triangle, and that's going to be 1/2, and our base and our height are going to be the same because it's a right triangle. 3 times 3. So when we do that, we're going to get, what did I get? I got 7.07 here, and I got minus 4.5 here. So that's going to give me 2.57. And again, it's going to be inches squared. Remember that, okay? When we talk about number 12, we're going to change this pi to 180. So we're going to do 2 times 180 divided by 3. That's going to give us 120 degrees. Here, 4 times 180 divided by 5. That's going to give us 144 degrees. And then we've got 180 divided by 2. Sorry, I don't know why I put a 20 there. 180 divided by 2. And that's going to be 90 degrees. So with number 13, we need to read this problem carefully, and we need to see what parts of it are important. It says, suppose you have a circle A and a circle B, which both have central angle measuring 20 degrees. Additionally, circle A has a radius of 5 over 2 feet, and the radius of circle B is 11 over 2 feet. If the measure of the sector for the circle A is 25 over 72 pi feet squared, what is the measure of sector for our circle B in radians? So we're trying to find the sector for circle B. So we've got our central angle measure of 20 degrees here, and we can see also that the radius here is 11 over 2. So what we want to do is 11 over 2 squared. That's our radius. We're going to multiply that times 20, and then we're going to divide that by 360, because remember, our formula is pi radius squared theta divided by 360, right? So when we do that, when we do the 11 over 2 squared, we get 1.68 pi. And if it was in a fraction, we can push math and 1 in our calculator, or we can just basically do 121 divided by 72 and see that we get 1.68 pi. And again, that's going to be feet squared.